Hi students, in today's class I am going to discuss solution chapter important numericals. So which is very easy if you have command in formulae. In previous video I gave formulae which is weight of solute, weight of solvent and what is W2, M2, what is W1, M1, what is the related formulae I had given. Please go through that video solution part 1 and come back to the part 2. So here I am going to discuss 7 to 8 numericals which is frequently asking in examination. Okay, first let's begin with the first numerical. Vapor pressure of pure benzene at a certain temperature is 0.850 bar. A non-volatile, non-electrolyte, they are not mentioned. What is a non-electrolyte? What is a non-volatile solute they are adding? Okay, colligative properties are properties which are depends on only number of moles of solute particles irrespective of the nature. If you add more number of solute particles, more elevation in boiling point, more lowering in vapor pressure, more depression in freezing point, more osmotic pressure, irrespective of the nature. If you add more number of particles, more colligative properties. That's it. Simple logic you can remember, keep it in mind. In non-volatile, what is a non-volatile? They are not mentioned. If they are not mentioned, definitely that you have to calculate. I am telling the logic here. What if they mention cane sugar like urea, no problem. But they are not mentioned means definitely molecular mass only they will ask. Solid weighing 0.5 gram when added to 39 grams of benzene. See students, afterwards what happened? Vapor pressure of the solution decreases 0.845 bar. What is the molar mass of the solid substance? This is related to relative lowering of vapor pressure numerical students. What is the related formula? So in previous video I had given all formulae, right? So once again I am writing here. What is this? P10 minus P1 by same thing P10 equal to W2 by M2 into M1 by W1. So what is W2? Solute. What is solute? This is 0.5 gram. This is 39 gram. Which is the less part? That is solute. Easy, right? And what about W1? Definitely 39. Okay, this one only they mentioned here, molar mass of benzene, that is only solvent. This is W1 is nothing but solvent. This is solute. Solute, solvent. Yes, solvent molecular mass they had given M1 equal to 78. Right. So afterwards, what they had given students? See, vapor pressure of pure benzene. Pure benzene is nothing but solvent. Pure benzene is nothing but solvent. Right. So that you can mention this P10. P10 is nothing but pure solvent. That is 0.8. And solution. What is solution? PS or else P1. Your wish. Anyway, you can take it up. Yes, this is PS. Solution vapor pressure always less than that of the solvent. So previous video I gave theory explanation also. Watch it, you will get more idea. Then you can substitute here. What is the students? First one always higher value. 0.845. Like that also you can remember. 0.85. Students, what is M2? We have to calculate, right? We have to calculate. What is M1? 78. 78 by W1 how much? 39. That's it. Cancellation terms you can cancel. After that remaining terms you can simplify. You'll get answer. Okay. So now look into this 0.5 into 2. This is 1 by M2. Right. What about this guy? This is 0.005 by 0.8. So finally if you simplify, you will get answer. What is the answer students? 170 gram per mole. Okay, simplification is easy. You can work out. M2 you have to calculate. Okay, M2. So M2 equal to how to write students? 0.80 by 0.005. That is your answer. Clear students? That's all. You can do like that. You'll get the answer. Now go to the next question. With units we have to write. Okay, what is the next question? See. To save the time, I have copied some questions. No? So remaining solutions and other questions also I'll explain. See, boiling point, elevation in boiling point. Boiling point of benzene non-volatile solute. What is the related formula? Delta TB. What is here? Molality. Expand this one. W2 into 1000 by M2 into W1. This is the overall formula. Okay, here what they are asking, boiling point of benzene, that is pure benzene. How much they have given? Actually, delta T. What is the formula we have to calculate? TB minus T naught B. This is what solute boiling point. This pressure is inversely proportional to boiling point. Above case, vapor pressure of solution decreases, means boiling point definitely increases. This is solution higher value first. What is the T? What is the T naught B? Pure benzene. Boiling point of benzene, only benzene. T naught B. How much? 3 solution, right? The boiling point raise it to, see, this is 354 point. Okay. Now, next one, what they are asking. One, after that container, the boiling point of benzene and when 1.80 gram of non-volatile solute, see, solute, W2 equal to 1. It dissolved in 90 grams of benzene, that is W1, which is excess solvent, right? So, next what they given? What they had given? Kb. Given 2.53. So delta TB indirect information they had given, you have to calculate. Then finally what we are going to calculate? See what we are going to calculate? The boiling point raised, calculate, yes, molar mass of the solute. That means M2. That's it, students. Same like above formula, above calculation, M2 they are asking. So substitute here. Clear? M2 equal to into 1000 by, can you tell, delta TB into W1. Yes, every term we have written, just you can substitute, you will get the answer. 3 into W2, how much children? 1.80 by, yes, what is this? Delta TB. Delta TB we have to calculate, right? Sometimes they are giving direct information, sometimes they are giving indirect information. Calculate your delta TB. Delta TB to TB solution, boiling point minus solvent. What is the value here? Higher value. If you are giving higher value minus lower value, 0.23. How much you will get answer, students, here? Yes, 0.88. You will get it. That you can substitute here. That's it. 0.88 W1, how much? 90. So simple calculation terms we can cancel and simplify. So finally we will get answer here 58 gram per mole. That's it. Okay. So see here, there is no need to apply logarithms, but calculations also simple parts they will give, simple way they will give. So easily you can score marks here, students. Okay. Now next one. Depression in freezing point. See, 1 gram of non-volatile solute dissolved in 50 grams of benzene lowered the freezing point of benzene 0.40 Kelvin. Freezing point depression constant of benzene is 5.12 Kelvin kilogram per mole. Only units also they will ask sometimes. What is the freezing point units, depression in freezing point, elevation in boiling point, units Kelvin kilogram per mole. Find the molecular mass of solute. Here also they are asking molecular mass of solute. Right. What is the related formula, students? Delta TB we can write delta TF, freezing point, KF. KB instead of KB, KF into M. So KF into W2 into 1000 by, tell me students, M2 into W1. So can you write given data, non-volatile solute, W2, how much? 1. Right. So next one, W, gram, right? So what is this? Lower freezing point, 0.40 Kelvin, 0.40 Kelvin. Delta TF also directly they had given, you no need to. Indirect information. If suppose indirect information they had given delta TF, how to calculate, students? Do you have any idea? Delta TF equal to, what is this? T naught F minus TF. This is the formula actually. But here no need. Directly they had given one value that you can substitute. Freezing point constant, that is nothing but KD. See, everything in your hand, calculate delta TF. So finally what they are asking, M2, interchange these two. M2 equal to KF into W into 1000 by delta TF into same questions. Elevation in boiling point, depression in freezing point. If you know formula, that's it. And after that, data writing is important. So weight of solute, weight of solvent. If you confuse, if you take ulta there, so entire question will be wrong. Less part is solute, excess part is solvent. Okay. KF, what is the value? Yes, 5.12 into W2, how much? 1 into by delta TF, how much, students? Yes, 0.40 to W1 we can cancel, and the remaining values we can simplify. Try to give answer. Okay, for one you can do calculation part. 5.12 into, what is the answer? And even calculated. 5.12 into 100 by, how much, students? 0.405, nearly same. So 100 by 0.40. Finally, you get answer. If you take proper values, you'll take answer 256 gram per. Always we have to write with units answer. Clear, students? That's all. Next, one numerical from osmotic pressure. Yes. From colligative properties only you can expect numericals. 200 ml of an aqueous solution of protein contains 1.26 grams of the protein. The osmotic pressure of such solution at 300 Kelvin is found to be this much osmotic pressure. Calculate molecular mass of protein. Students, one theory question also I am giving here. Protein and macromolecules, like macromolecules is nothing but polymers. Polymers, molecular masses, definitely the perfect colligative properties is osmotic pressure. So big long chain molecules, macromolecules, polymers, proteins, molecular mass calculation by using osmotic pressure. Question. Okay. Next, what are colligative properties? Lowering of vapor pressure, elevation in boiling point, and depression in freezing point, and osmotic pressure. Basically, we have questions. These colligative properties depends on only solute particles. Solute particles. Sometimes they won't mention, just they will give question like this. Okay, I'll give you, once we'll complete this part, I'll give you theory questions also. Now first come back to this one. Volume, how much, students? Volume 200 ml. Okay, this is the solute weight. W2 is 6 grams. Osmotic pressure, how much they given? Osmotic pressure 5 bar. Next, molar mass they're asking. Temperature, how much? 300 Kelvin. This is the given data, right? Now, what is the related formula, students? Yes. Previous video we have discussed, no, pi equal to C into R into T. What is C here? What is this? C is molarity. Molarity is right. So number of moles of solute present in 1 liter of solution, which concentration we are using? Molarity concentration term. That's it. Molarity, how to write, students? Expand. Number of moles of solute by volume in liter. That is in R into T. Right. So here numerical they are given in ml. So then finally what you will take your formula? I equal to N2 by W2. Okay, one second. What is N2, students? N2, how to write? Yes. Number of moles equal to weight by gram molecular weight. Number of moles equal to, what is this? Weight by molecular weight M2, molecular weight, right? So pi equal to substitute W2 by M2 into R into T into 1000 by volume in M. This volume here only, volume term here only. If you will take liters, don't take 1000. If you are taking ml, so you have to divide with 1000. So then only your answer is perfect. You can substitute W2 how much, students? 1.26. R value depends on pi. So pi here they had given bar. Even R value also you have to take it in bars. But R value we are taking in joules, calories also. Calories 2, 1.98. Joules 8.314. But here they had given bars, means you also take it same thing. 0.083 bar. Okay. Liter, bar, Kelvin in taking bar. That's all. Substitute R value 0.083. They're given in Kelvin only. Sometimes they will give in degrees. You have to convert. So 1000 by M2 you have to calculate, right? Interchange. Pi value comes here. 2.9 volume how much? 200 ml, right? You can cancel, and remaining you can go for simplification. So finally we'll get answer here 61,022 gram per mole. Whenever gram molecular weight you are calculating, gram per mole units you have to express. See, big molecular weight, biggest 60,000 above, 50,000 above you are getting, means molecular weight is heavy protein and macromolecules, giant molecules, right? So which concentration term, which colligative property we are using? Osmotic ratio. Next, this is one of the most important model under osmotic pressure. See here, isotonic solutions they have mentioned. Isotonic solutions. Isotonic solutions is nothing but same osmotic pressure. Same, right? Same osmotic pressure. So that means pi 1 equal to pi 2. That is nothing but C1 equal to 2. What is C1? Concentration. That is nothing but N1 you present in 1 liter of solution. Okay, first you come back to the question. If 5% solution of cane sugar is isotonic with 1% solution of the substance X, what is the molecular mass of X? So first you have to write expanded form. 5% is nothing but 5 grams of solute. 5 grams of solute. What they mentioned solute here? Yes, cane sugar. What is the formula? 342. Okay, is isotonic. 5 grams of solute present in percentages. That means 100 ml solution. The same way you can express this one also. 1% solution is nothing but 1 gram. 1 gram of solute, 100 ml solution. Important matter. So now you can substitute. Here 100 ml, 100 ml. V1, V2 is same. V1 equal to V2. If V1 equal to V2 means you can cancel, no? V1 equal to V2, cancel. Remaining one is number of moles. But number of moles directly they were not given, no, weight form. So what is the formula? Number of moles calculation, weight by gram molecular weight, right? So weight by gram molecular weight. Yes, you can substitute here weight by gram molecular weight. You can write W1 by M1 equal to W2 by M2, right? W1 how much? 5 by, so see here molecular mass 342 equal to W2 how much? 1 by M2. M2 we have to find out. That's it. So now finally M2 equal to 342 by 5. We will get answer here. Yes, 68.4. This is one of the most important model into competitive examination. Okay, competitive examination, this plays important role. 5% solution expansion, 1%, 2%, 10%, like that they can mention. Always, what is the number? That's gram solute. 5 grams in 100 ml of solution. Like that, we have to express the question. Okay, students. Now, come back to the next question. Among the following, which has the highest elevation in boiling point? Okay, colligative properties are properties, colligative properties are properties which, which depend on number of moles of solute. Number of moles of solute, most important point. If we add more solute, more colligative properties. Okay, what are colligative properties? Relative lowering of vapor pressure, elevation in point, depression in osmotic pressure. Sometimes to confuse the student, they don't mention relative lowering, just vapor pressure, just boiling point, just freezing point, osmotic pressure. That time osmotic pressure only colligative property. If they mentioned relative lowering of vapor pressure, that only colligative property. Elevation in boiling point, that only colligative property. Just boiling point, that's not colligative property, students. To confuse the students, sometimes you may expect theory questions like this. Okay. Finally, here they are given 4 options. You can calculate. So NaCl. NaCl, how it can dissociate, students? Na plus Cl minus. If you put in water, 1 plus 1, how many particles? Option 1, 2 particles. Option 2 also similarly, you can barium chloride, how it can dissociate? Barium plus 2 Cl minus. How many particles here? 3. Number of particles, N equal to 3. Here N equal to 2. Here, no association, neither association nor dissociation. Better word. No association, no dissociation also you can. Okay, Van Hoff in their detailed explanation I am going to give. Strong electrolytes, weak electrolytes, non-electrolytes. After that, why we are modifying the colligative properties. So I am going to explain Van Hoff factor numericals and shortcuts also. Okay, no association, no dissociation. Here N equal to 1 only. Okay, next 4th one. What is the 4th one, students? Yes, aluminum sulfate. How we associate? Aluminum plus 3, 2 moles of aluminum plus 3 and 3 moles of sulfate. 2 plus 3, 5 particles. 5 particles. Where number of particles is more? 4th option more. So it has more colligative property, that is more elevation in boiling point. Clear? That's all. Now next one more question. Van Hoff factor I for a dilute solution of strong electrolyte barium hydroxide. So barium hydroxide, Van Hoff factor is represented by the I equal to 1 minus alpha. Okay, I am going to discuss this numerical shortcut also, 1 plus alpha into N minus 1. So we are taking your barium hydroxide, they are asking how to take barium hydroxide to barium plus 2 hydroxide minus. So 1 plus 2. How many particles? 3 particles. Alpha equal to N equal to 3. N equal to 3. So you can write option 4. So we are using this formula and you are using this one also. Anyway, you can calculate. When we use this one, I'll explain. If alpha equal to 100% dissociation, then alpha equal to 1. Alpha 100% dissociation is nothing but alpha equal to 1. You can substitute, suppose here I equal to 1 minus 1 plus, what is this? 3 minus 1. Minus 1 into 2. Okay, what is the answer here? Sorry, this is 1 plus. 1 plus. Okay, 1 plus 2. Totally 3 particles. You can go for this way calculation or else you can go for this way calculation. Finally, answer is 3. So that means 4th option. Okay, so next video, I am going to explain explains want of factor numericals. Why want of factor? Why I introduced it? Okay, we'll discuss. Thank you, students. Thanks for watching and inform to others also. So definitely this is useful in examination.